Now we've gone over long division, but there's also something called synthetic division, which is a very efficient way to do division. Now we have to be a little bit careful with synthetic division in that with long division, at least we had place values of the powers, and if we didn't have like our place value, we would notice that our powers don't line up. Okay, and that gives us an idea that we might have done something wrong. With synthetic division, we're just going to avoid writing the powers in. Okay, so we're just going to use the coefficients. And when we do this, the problem is that if we forget our placeholder, so in this case, cube, squared, we need a power 1, so we need that power 1 placeholder. If we forget it, it's hard to tell that we've actually forgotten it. Okay, so synthetic division really is just a quicker way to do long division. It's more efficient. So here we have, the way it works is that we're just going to take the coefficients and then we're going to take the root. Okay, so when we divide, some people like to use the root. I use the factor -3. Some people use the root. If you use the root +3, okay, we have to add. Here I'm using -3 and we'll subtract just like we did up here, because really we're just doing the same thing. I'm just going to use here they use +1 and subtract. Well, I'm just going to use whatever's there and subtract just like we did in regular long division. Okay, but there are other ways to do it, and if you see it done differently, just remember that if you have used the opposite sign, you don't subtract, you're going to add. So the way it works is this. The first thing we do is we just bring down that power, okay? Because if we have a 1 here, that 3 indicates that's going to be our first coefficient. Okay, and I'm going to do this in red because it's going to give us a quotient. Okay, so we just bring down that first coefficient, and that becomes the first coefficient on the quotient. And what we do is this. We multiply -3 times 3, we get -9, and then we're going to subtract. And this is really just taking that next term and lining it up with this term here. And we get +10, so we're subtracting. Okay, and then we do the same thing. We times that, and we get this, so it goes up like that. We get -30, and then we subtract. Okay, so we get +30 in this case. And then we do the same thing again. We do it one more time. We come across like that. We put the number over here, so we're going to end up with -90, and this last term represents our remainder. So -1 minus -90 gives us +89. Okay, and this works out to be a remainder. Okay, now I can show you how this works in long division as well, so you can see exactly what's happening in the long division. Okay, it's exactly the same thing. It's just we're just kind of doing it without all the x's involved. Okay, so here we have x minus 3. Here we're going to end up with 3x cubed plus x squared plus 0x minus 1. And you can see that our division, so we get the 3 here, so that's how we get the 3x cubed, and then 3 times -3 gives me the -9. Okay, so that's how I get the 10x squared plus 0x, and then the next number is, well, I need to plus 10x here. Okay, so 10x, we get 10x squared. 10 times -3 is -30x, and that's where we get this -30 up here. Okay, subtract, we get 30x. Bring down that. We need to go plus 30. Okay, so that's where the plus 30 comes from down here. So 30 times x times -3. So we get 30x, and this is where the -90 comes. Okay, so there's my -90 up there, and then I get a remainder of 89. Okay, so really it's the same thing. And notice now what happens is these coefficients represent the coefficients of my quotient. Okay, so this is just a quicker way to do long division. Now, where it gets kind of useful is that when we have to do lots of division, we can do it more efficiently if we can do it in synthetic division. So what I can do is, when I'm dividing by this quadratic here, I can actually factor this quadratic into x plus 1 and x plus 2. Now we have to be careful. The method I'm going to show you relies on having no remainder in the first term. Okay? Because if I divide, I'm going to generate by one factor, I'm going to generate the remaining term. So what I'm going to do here is I'm going to divide by x plus 1 first. So I'm going to have plus 1. Then I'm going to set up my synthetic division. The coefficients are going to be 1, 5, negative 7, negative 41, negative 30. So I'm going to just divide by one factor first. So I can get 1 times 1 is 1, so 5 minus 1 is 4. 1 times 4 gives me 4 here. Subtract, I get negative 11. 1 times negative 11 is negative 11. I minus, I'm going to get negative 30. 1 times negative 30 gives me the negative 30 here. And then this gives me my remainder of 0. Now, my cubic, when I divide by x plus 1, I'm left with a cubic function, which is x cubed plus 4x squared minus 11x minus 30. Now I can do that and set it all up again, but really it's already set up to do my synthetic division one more time. Okay, so then it looks like this. I can just reapply my synthetic division. So I now have divide by plus 2. Okay, so I'm going to have bring down my 1. Okay, in fact, I'm just going to do it in red here. Just bring down my 1. 1 times 2 is 2. Subtract, I get 2. 2 times 2 is 4. I subtract. I'm going to get 15, negative 15. Okay, 2 times negative 15 is negative 30. I subtract, I get a remainder of 0. So my quadratic that I generate when I divide this fourth degree here by this quadratic, now I did it in 2 steps, I'm going to end up with, my quotient is going to be x squared plus 2x minus 15. And I can rewrite this in my division statement. Okay, I know that x to the power 4, I'm just going to write it all out here, minus 7x squared minus 41x minus 30, that's equal to my divisor, x squared plus 3x plus 2 times my quotient plus my remainder. And my remainder in this case is 0 plus 0. Okay, so there it is. I can use my synthetic division and layer my synthetic division like this to make it a little bit easier, not necessarily easier, but more efficient. Okay, but this layering relies actually on getting a remainder of 0 though. So you have to be a little bit careful with this if you're going to use it for dividing by these quadratic terms.